This is R.d.sharma solution class 12 chapter 19. Exercise is 19.20. Indefinite integrals we are talking about. Now 3 questions we have already done. There are certain things which I told you that we need to make x square plus 1 in form of x square minus 5x plus 6. And then we added and subtracted certain thing in the numerator to form x square minus 5x plus 6 so that we can get some 1 plus something. We have already done that in the previous questions, but some of the students may find it troublesome. So what we will do here is we will do the same thing but with a different approach. We have x square minus 5x plus 6 here. Now we will divide them, that is x square plus 1. How to divide? You need x square, so you have to multiply 1 here. So whatever is coming, what are you going to get if you multiply this whole with 1? X square minus 5x plus 6. And when you subtract this, the sign is going to change. Actually what we are doing here is x square plus 1. We are subtracting x square minus 5x plus 6 from this x square plus 1. So in order to complete this division, I'm just showing you what this difference means. So I'm opening the negative with a bracket. So all the sign will change. X square gets cancelled. 5x will remain there. And 1 minus 6 will be negative 5. Now how do we write this? If you have known it 7th, 8th class or grade, we have already done this. It is written as 1 plus 5x minus 5 divided by x square minus 5x plus 6. You know it already and you can check it also. By taking the LCM, you will get the same result which is the question incidentally. So you multiply x square minus 5x plus 6, you add 5x minus 5, you will get x square plus 1 only. Denominator remains the same, x square minus 5x plus 6. So the previous questions where I added and subtracted something on the numerator and then we got this one, and in this case we have applied a different approach. I showed you that division has to be done so that we can get this thing. So both the approaches are in front of you. Whichever you find it convenient for your sake, you can go ahead with this. Now let us integrate this with respect to dx. X square minus 5x plus 6. Can we do something with this so that we can get 5x minus 5? So this 6, see x square minus 5x plus 6, 6 can be written as 2 into 3. Negative 5x can be written as negative 2x minus negative 3x. So you can just take this x outside, x minus 2 will be there, negative 3 outside, x minus 2 will be there. So this x square minus 5x plus 6 is now the factor of x minus 2 and x minus 3. So this first one will be x only. You already know that. We'll use it in the later part. The second part, we will do it or we will solve it in a way of partial fraction. That is fx, this 5x minus 5 divided by x square minus 5x plus 6. We can write it as x minus 2 into x minus 3, that we already seen because we have factored them out. This will be equal to a divided by x minus 2. We don't know what is a and what is b, but still we want to separate this 2 out, x minus 2 and x minus 3, so that we get a proper integration. We know the integration result. So b by x minus 3, that is how we can differentiate or we can present this as a partial fraction. Now take the LCM, a into x minus 3, b into x minus 2, and in the denominator you will have x minus 2 into x minus 3. So this x minus 2 and x minus 3. On the left, it is f5 minus 5, x minus 2 and x minus 3. You can just cancel this denominator here. Now you can just equate this. Similar term, so this will be ax minus 3a plus bx minus 2b. And on the left, you have 5x minus 5. So what are the similar terms? Let's collect them first. Ax plus bx will be a plus b and x will be there. Then we have negative 3a and negative 2b. You can just take negative common. You'll get 3a plus 2b. And you can now equate it with the similar terms. A plus b will be equal to 5. 5x is actually equal to a plus b into x. That is, a plus b is equal to 5. This is the first equation we are getting. X gets cancelled. A plus b equals to 5. The second will be 3a plus 2b equals to 5 because this negative is already outside, so we don't worry about that. 3a plus 2b will be equal to 5. Now a equals to 5 minus b you can write, or b equals to 5 minus a. or rather you can multiply it by 2. So when you multiply, you get 2a plus 2b equals to 10. Now you can subtract these two. So when you subtract 3a minus 2a is a, 2b and 2b gets cancelled, 5 minus 10 is negative 5. So a is negative 5, and you already know a plus b was equal to 5. So a is negative 5. What will be b? B will be equal to 5 plus 5, which is going to be, this goes here, b will be equal to 10. So this is all you have already done in the previous standards. Now we will go forward with the integration. So this equation 1 is very important because we have already got a, which is negative 5. You can take this negative 5 outside. You will get dx divided by x minus 2. A is negative 5, so dx by x minus 2. The second term, plus is in between, so just write this p. b is 10. I will take it outside and I'll remain with dx divided by x minus 3. So we are integrating these two terms now. It will be negative 5. This will be simply log modulus of x minus 2. Same here, 10 log modulus of x minus 3. But there is x remaining because it was previously done, integration of dx was x, so I'm adding it, and I just have to add a constant of integration, which I will append in the later part, and this is the whole solution. This is the complete solution. Now this is the way you are going to go about it. If I have left any of these steps, you can get it from here, and this is the way you are going to solve it. Okay, 6th, 7th, 8th, 9th standard is very important in order to solve these kind of question efficiently and easily. X square divided by x square plus 7x plus 10. Now if you don't understand that what to add, what to subtract, then there are two ways you can do it. Either you add, subtract something to the numerator so that you get a denominator as it is, or you can just divide. Division will give you a proper solution that can be easily integrable. So this is x square plus 7x. I'm adding 7x and subtracting 7x because I need a 7x. I need a 10, so I'll add a 10 and subtract a 10. So x square plus 7x plus 10. These three, I'll combine them or collect them together. And the terms which I have, which are left out, which is negative 7x and negative 10, I'll just put a negative sign and place the 7x plus 10 as positive. So I'll just write 7x plus 10. This is the numerator. What is the denominator? It's x square plus 7x plus 10. So I have added 7x, subtracted 7x, added 10, subtracted 10, and then we have got something which is actually matching the denominator. So the denominator has to be put down below both the terms. So x square plus 7x plus 10, x square plus 7x plus 10 here. Now the first term is 1 because it gets cancelled out. 7x plus 10 divided by x square plus 7x plus 10. Now can we get something out of it? This integration will do, but before that we have to comprehend the division also. If you divide these two, you will get the same thing. So 1 minus 7x plus 10 divided by x square plus 7x plus 10. Let's integrate both the terms with respect to dx now. First term will be simply x, integration of dx is x only. The second term is this one. X square plus 7x plus 10. Can we write this in terms of factors? If we can write, then it will be easy for us because it will just match the previous question. 10 can be written as 5 into 2 and 7 can be added as the sum or the subtraction of 5 and 2. So x square plus 2x plus 5x we can write plus 10. X you can take common, x plus 2 it will be. You can take 5 common, x plus 2 it will be. So this x square plus 7x plus 10 has become x plus 2 into x plus 5, which are the two factors. Now 7x plus 10 as per the previous question divided by, we will write x plus 2 into x plus 5 rather. We will not write x square plus 7x plus 10. We have already made the factor of it. So x plus 2 and x plus 5 will remain here. And this we will write, we don't know the result, but we'll write it as a divided by x plus 2 and plus b divided by x plus 5. Now let's take the LCM, a into x plus 5 plus b into x plus 2, and the denominator you have x plus 2 and x plus 5. Just multiply them and keep it in the denominator. This is 7x plus 10. In the denominator you have x plus 2 and x plus 5. Now you can just cancel these two denominators and then multiply the right term and equate it with the left terms, similar terms. 7x plus 10 will be equal to ax plus 5a and bx plus 2b. separate the similar terms, that is a plus bx and 5a plus 2b here. 5a plus 2b, now just equate these two. A plus b will be equal to 7. This will be equal to 7, first thing. This is your first equation. 5a plus 2b will be equal to 10. That will be your second equation. Now what you can do is you can just multiply this equation with 2. So when you multiply, it will be 2a plus 2b equals to 7 to the 14. You can subtract these two equations. 5a minus 2a is 3a. 2b gets cancelled. 10 minus 14 is negative 4. So a becomes negative 4 by 3. When you put this in the first equation, b will be equal to 7 minus a, which is 7 minus of minus 4 by 3, that is 7 plus 4 by 3 it will be. So 7 3s are 21, 21 plus 4 is 25, 25 by 3 it will be. So 21 plus 4 by 3, 25 by 3 it will be. So b became 25 by 3, a we found to be negative 4 by 3. Now just concentrate on the equation which was initially I made. This one I am talking about. This is equation number 1. And place this a outside, which is negative 4 by 3. Keep everything inside, dx by x plus 2. And the second equation will be what? Or second term rather. It's 25 by 3. So just plus 25 by 3 outside, integration of dx divided by x plus 5. So now it's simple integration of log. Negative 4 by 3 remains here. There is a negative sign outside. We'll deal it with later. Log modulus of x plus 2 plus 25 by 3 log modulus of x plus 5. Now this x has to be added and there is a negative, so we'll change the sign. It will be plus 4 by 3. This will be negative 25 by 3 plus constant of integration, and that's your final answer. So let me write the final answer just for the sake of completion. This is the final result I am writing. X plus 4 by 3 log modulus of x plus 2 minus 25 by 3 log modulus of x plus 5 plus constant of integration. So if the basic things are clear to you, this will be easier. So this is the second option which I am giving you. I added 7x and subtracted 7x, added 10, subtracted 10. But the same thing can be done using the division also. That division you can apply if you are comfortable with it. If you're not comfortable, then you can follow what I have suggested you. Alright. Once you write this, the factors will make it very easy to integrate, because integration result of dx by x is known to us. Next is, this is x minus 1 whole square. This is the question, and divided by x square plus 2x plus 2. Now we have to integrate this. This is the question. Now the thing is, x minus 1 whole square, how to do this? There will be a confusion, but don't worry about that. X minus 1 whole square will be simply a square plus b square minus 2b, x square plus 1 minus 2x. And this is divided by x square plus 2x plus 2. Now you can add or subtract something in the numerator in order to get the denominator. Or you can just divide these two in order to get the same sequence of events that we have done in the previous two questions. So the best way, x square is already there. 2x is not there, add 2x, subtract 2x. 2 is not there, so if you add 2, subtract 2. Now collect these similar terms, or similar the term which is matching the denominator. So x square plus 2x plus 2 I am combining. These all x square plus 2x plus 2. And what all is left? Negative 2x will be negative 4x. 1 minus 2 will be negative 1. So you can just place a negative sign in front and write 4x plus 1. But denominator will be below both of these terms. X square plus 2x plus 2. Here also 4x plus 1. And you have this in the 4x plus 1. Denominator will remain same, x square plus 2x plus 2. Now this gets cancelled. 1 minus 4x plus 1 divided by x square plus 2x plus 2. Now can you make the factor of x square plus 2x plus 2? Let's integrate these two now. You know already the first result, which is x. I'm keeping it in a box so that we can deal with it later. Now you can't have the x square plus 2x plus 2 as a perfect square. So if you're not able to make the factors, the best way is to represent this 4x plus 1 as the differentiation of the denominator. So 4x plus 1 will be equal to a into d by dx of x square plus 2x plus 2 and plus constant of integration which is, plus another constant which is b. So 4x plus 1 will be equal to, this differentiation will be 2x plus 2. A into 2x plus 2, so it will be 2ax plus 2a, and there is a b also, so 2a plus b. Now these are two separate terms, we can equate it with the similar terms. 2ax is equal to 4x, and the second will be 2a plus b will be equal to 1. This will give you x's gets cancelled, a will be equal to 2. Now put this a on the right hand side equation, which is 2 into 2 plus b equals 1. So b will be equal to 4, so 1 minus 4, it will be negative 3. B is negative 3. So this was the equation I was talking about, and just put it here. And now integrate. That is, I am talking about the second term here. X is already there, we'll deal it with later. So I am integrating 4x plus 1 divided by x square plus 2x plus 2. We have already made 4x plus 1 as a into 2x plus 2 plus b. A is 2, b is negative 3. So take this a and b outside. So this is 2x plus 2. So 2x plus 2. Denominator will be there. X square plus 2x plus 2 will remain there. So write this x square plus 2x plus 2 here. Now what is b? B is negative 3. So negative 3 you can take it out. And what is the integration? Dx divided by, I am talking about b. So b is negative 3 or taken outside, x square plus 2x plus 2 will remain in the denominator. Now this you call it as I1, this you call it as I2. I1 will be simply, you know the denominator, the numerator is the differentiation of the numerator is the differentiation of denominator. So if you take t equals to x square plus 2x plus 2, this dt will be equal to 2x plus 2 into dx. So you have got the numerator dt divided by t integration, and this will be log modulus of t plus constant of integration. Call it as c1. So this will be log modulus of t was what? X square plus 2x plus 2 plus constant of integration c1 you can call it. 2 is already there outside, so I have made it as 2. I2 will be what? X square plus 2x plus 2. You have to make it as the perfect square because there is no other option left. This 2, which is the coefficient of x, divided by 2, you will get a 1. That is x square plus 2x plus 2. You have to take the coefficient of x. Divide by 2, which is 1. Square it, 1. Add it and subtract it. So you will get x square. This x square plus 2x plus 1 will be x plus 1 whole square. And 2 minus 1 will be 1. So you can call it as 1 square. So this whole will be negative 3 will be there. And integration dx divided by x plus 1 whole square plus 1 square. So x square plus a square, you know, 1 by a, tan inverse x by a is 1 here. So don't worry about the a. It will be simply tan inverse x plus 1 and preceded by negative 3. So tan inverse 1 will always be there. Just for the sake of completion, let me write 1 here also here. So what will be the final term? Negative 3 tan inverse x plus 1. Okay. So we have I1 and I2. We have to combine them first. C1 was with I1, C2 was with I2. So first term is x, I am writing x. The second term have negative, so I am just changing the sign of I1 and I2 and adding it up. So 2 log modulus of x square plus 2x plus 2, and then we have this 3 plus 3 tan inverse x plus 1 plus C1 plus C2, let us call it as capital C. So this is the final constant of integration. This is your final result. Or for the sake of completion, let me show you the result which you are going to follow. You can do it by any way you want. This question we are going to take in the next discussion. Till then, thank you so much and have a good one.